Sorry, back to your question. So you were asking about this section up here, right? Go ahead and finish your question for me.
I was just wondering if formatting in that way with the three quotation marks at the top and bottom made it automatically return on the whole line.
Yes, it does. And the reason why is because in this particular example, I specified that long text would be in Markdown. So long text is here. Let me see if I can get it all in one screen. So this long text is in the triple quotes, and then it has underscore for italics, and the bullet points are stars, and the return statement at the end of each line actually successfully gives a new line. And the reason for that is because the div that it's in is actually using the dash core components markdown element. And as we've seen in Jupyter Notebooks, markdown is a little different from the way things come out when you simply print. Okay? So if we were to drop this into a Jupyter Notebook and convert it into markdown, we would see similar results. Okay?
Thanks.
Yeah. That's a great question. And we are, in fact, recording, so that's great. Okay, for the next one, given any two strings, print fizz if they do not have the same number of letters, and buzz otherwise. Okay, so we defined my function to receive any two inputs. And here I've got it specified as this and that, but I think it's probably better to have them listed with something like x and y to keep it short. And we just want to check that if the length of x is not equal to the length of y, print fizz, else print buzz. And then we'll test it out with my func, I don't know, pizza, cheeseburger, and that's a fizz, but pizza and backwards pizza is going to be a buzz. So that's a simple way to do this. And keep in mind, by the way, if you've never seen it before, fizz buzz is just like standard job interview Python write a function. They always ask for outputs of fizz and buzz. I don't know why that is. I think there's some history to it that goes back beyond Python to the early days of computer programming, but it's kind of gotten baked into these sort of simple write a function exercises. Write a meaningless function that shows off your skill. But there is another way to do this. Rather than receiving x and y as inputs, a little more complicated way to do this is to receive arguments using wildcard args. And this is a more sophisticated way to write this same function, right? So then you would say if the length of args is equal to 2, then you would want to go ahead and do something. And then you would say if the length of args 0 is not equal to the length of args1, then print fizz, whoops, else print buzz, and then an outer else statement that would be print, please provide only two inputs. And now you would try that same thing with pizza. And I've got a error message here, which is erroring here, this if statement of args. What have I got there? I think, have I got too many parentheses?
There's not one closed.
Thank you. Perfect, that's exactly what it is. And then I had too many over here. There we go. And then if I add another element, then it'll give me the expected error message. So same thing in two different ways. It's not wrong to write it like this, but this gives you more flexibility and makes your code not only more reusable, but more robust. Robust is a standard term for Python code that can handle a wide variety of inputs and still comes back swinging.
So is it accurate to say that's kind of like error handling?
Yes, this is a good example. Well, this is a good but simple example of error handling, yes. Okay, functions with string indexing. Given any three strings, return the third, second, and first letters of each and assign this to a variable. And I'll leave the other one up as an example. All right, so given any three strings, return the third, second, and first letters of each respectively. And then we want to return A, 2. This is a test in your indexing skills, B1 and C0. And then we would test it out by assigning it to a new variable called new var. Would take in myfunc, and let's do Lincoln, Washington, and Obama, and return new var, and it gives us back N, A, and O respectively, just as we expected it would. Next up, given any string, print its length, then grab everything past the first letter. So this is a test in string indexing again. So we've got the input is named string, and we would print the length of string, and then we would return string 1 and everything following my func. Hello world, 11 characters, no H. Stop me if you've got questions. Next up, given any string, grab everything up to the 3rd index and assign this to a variable. Try and add some error handling to this one. Okay, this one's pretty straightforward. Everything up to the 3rd index. You could simply return string bracket colon 3, and then try my func. Assign it to a new variable, of course. New var would be equal to my func any input, and then print new var, and we get any, and that's pretty good. But what if we wanted to add instead a wildcard and turn it into args, right? And by convention, we would call that args. So then we would say if length of args is equal to 1, then you would return, and instead of string, it would be args 0, because it still is treated as a list. And that gives us the correct input. But now if we give it more stuff, it won't error out on us. Instead it will, oh, I don't have an else statement, right? Else print 1 please, and that gives me my appropriate error message. Anybody else have an error handling on that one that they think is worth sharing with the class? Okay, the next one up. Use negative indexing to grab all but the last letter of any string and assign this to a variable. So I'm going to go ahead and dive right into the wildcard on this one, and I'm simply going to drop the star in front of value, turning it into args. And last letter of any string. We want to return value and everything up to but not including -1. And if it is an arg and you simply drop in the 0 index, you don't actually have to have necessarily any error handling. It will just ignore everything after the first inputted value, and that is actually fairly valid. And then you could, but you might at least want to have this. If type value 0 is a string, then you might return that, and then else
print string, please, right?
Could you also convert
Sorry.
like a linear or float to a string?
Oh, that's actually a pretty good idea. Do you know how to do that?
Say str. value?
Exactly. Else x is equal to str value 0. That's an excellent idea. And then you could return the same thing here, right? Let's see if that actually works. That's an excellent suggestion. So my func, with a basic string, it would just be, I don't know, dogs, right? So it dropped to s. But if we give it a number, integer is not subscriptable, and it's returning here because we didn't successfully turn it into a string. I would have expected that that would work.
Because at the return line, you have value 0 index instead of return x.
Oh, of course. Thank you. That's exactly what it is. Nice. Thanks for spotting that. Okay, we've got 5 minutes left. Let me skip a few of these. Several of these are fairly repetitive. String backwards, print it 100 times. That's exactly the same cell. Built-in string methods. If we never put them into a sentence. Yeah, let's just do these last 4. We'll finish with these last few here. Given any string, reverse it. Print 3 statements where you convert it to uppercase, lowercase, and then split the string on whatever is the third letter of the original string. The point here is write a function that uses dot upper, dot lower, and dot split. That's the idea. Okay, so we're going to use these 3 elements in our function. So we received x, and we create a new variable called s, and we set it equal to x backwards using colon, colon, -1. Keep in mind that this is everything and starting from the last element. And then we'll want to print s.upper. We'll want to print s.lower. And we'll want to print s.split. And we're going to split on whatever the second character of the original string is. And then we go ahead and we try my func. Let's feed it George Washington, and that gives it back to us as we expected, splitting on the O's. Now, of course, if I were to feed this an integer, then I'll get an error message because we'll need to add some error handling. And you can, of course, add error handling into the function itself, or you could build a second function that has the first function nested in it as follows. Define new func will receive some value, and we'll even turn that into args. Let's do it this way. Star args, and we can say if length args is equal to, actually let's do type because we want this to be string, a type. If the length of args 0 is string, then new var is equal to my func args 0, and return else, and return new var in a second. Think about that. Yeah, let's go ahead and return new var. Else, and just as we did in the last one, we can assign new var is equal to string args 0, and then new var, just using exactly the same line of code. But dropping it in here, I should probably give that a different name. New var, and let's call this new var 2, return new var 2. So what this does is, this time I've got my rope on the other side. We defined our earlier function, and rather than making this overly complicated with a lot of error handling in it, this is the nugget of what we want to do. And then we build a wrapper around it, which has the built-in error handling of number of arguments, making sure that the type is string, and then if it's not a string, converting it into a string. And then here, using the myfunc argument, and also here, using the myfunc function. Nesting function in this way is extremely common because it allows you to test each element by itself, make sure it works, and then have some sort of larger or master function that calls all of them stepwise or that has the error handling. So, and if I've done that correctly, then I can go ahead and try new func on George Washington. And that works successfully. But I can also try it on this number, and that works successfully as well. So this way of nesting functions is extremely Pythonic. It's very common. A terrible thing to do, and I actually see it all the time, and I've been guilty of this myself, is to write one super long function that has everything in it. Much better to break it out into smaller functions and then to wrap those all together into a final, also small function that simply calls each of the individual components. That's much better coding practice.
Keep it simple.
Keep it simple, exactly. Keep it simple, stupid. Okay. Well, it is 8:30. Let me go ahead and stop there. I think the rest of these are pretty straightforward, and if you look at the solutions notebook, you'll be able to follow along. But I hope this was helpful. We obviously did not get through more than 2 notebooks in this section, which was section 5. So I am going to go ahead and continue with this same set next time around. And as I've been doing in this one, I'll try and build in some of the more advanced stuff into the examples so that we don't get too far behind. Because I do think that lesson 6 is functions advanced. This is actually really important too, though, conditionals, loops. I don't know, I just feel like you can't spend too much time on this. But please do give me feedback in the exit ticket if you would like to speed things up. I'm always more than happy to do that. And there we go. All right, thanks everybody. Really appreciate it, and I'll see you on Thursday's class.
So should we go through functions lessons before? If we want to read ahead a little bit, do you recommend reading through?
Yeah, if you can come to class already prepared to cruise through this, then that would allow us to move more quickly. And I also think it would help all of this to sink in.
So all the functions lessons all set up?
Yeah, this is lesson 5. I believe there are 7 notebooks in there. 5. Yeah. If you can at least have some familiarity with these, the most helpful thing is to review lists, dictionaries, and tuples so that you're familiar with those. So, all right, thanks so much. See you Thursday.